One of the most important things about one-to-one functions is that we can define inverse functions for them. If we have a one-to-one function with domain A and range B, we can define the inverse function, which has domain B and range A, by saying that f inverse of y equals that unique value of x for which f of x equals y. And this is well defined, or satisfies the requirements for the definition of a function, precisely because each value of y in the domain of f inverse has exactly one x in A corresponding to it. We use this very important equivalence of equations. So the equation on the left, f inverse of y equals x, is the same as saying that f of x equals y. That's what this if and only if means. And we use it in three ways. Number one, just to find f inverse of y for a specific value of y without actually finding a formula for f inverse itself. We can also use it to find a formula for f inverse sometimes. And we can define new functions as inverses of well-known functions. Let's look at an example of a problem of the first type. If f of x is x cubed plus 1, let's use this equivalence of equations to find f inverse of 9. We start by rewriting the problem. Let x be f inverse of y, and that equation is exactly the same as the equation f of x equals y. Since we're looking for f inverse of 9, it makes sense to replace the y by 9 in the equation on the left, and since we're looking at an equivalence here, we can also replace the y by 9 in the equation on the right. So solving f inverse of 9 equals x is the same as solving for x in the equation f of x equals 9. Now, using our formula, we see that solving for x in f inverse of 9 equals x is the same as solving for x in x cubed plus 1 equals 9. That's the same as solving for x in x cubed equals 8, and that gives us x equals 2. So therefore, f inverse of 9 is equal to 2, because the x in both equations is equal to 2. Now, try to repeat this process yourself for f inverse of 28. I'd encourage you not to take a shortcut by solving for f inverse here if you've done that before. That's easy here, but I want you to master this method of solving for f inverse of 28 without actually having a formula for f inverse. Here's the solution. If f of x is x cubed plus 1, find f inverse of 28. Well, we first write down the equivalence of equations. F inverse of y equals x is the same as saying that f of x equals y. Now, plugging in 28 for y in both equations, we get f inverse of 28 equals x is exactly the same as saying that f of x equals 28, which is the same as saying that x cubed plus 1 equals 28, which is the same as saying that x cubed is 27, which is the same as saying that x equals 3. So therefore, f inverse of 28 equals 3. Note that sometimes we write this if and only if, are the same as saying, using this symbol in mathematics. This is the same type of problem, but finding the x, solving for x, requires a bit of guesswork. Let's look at the function g of x equals cosine x plus 2x, and we want to find g inverse of 1. Now, I know that g is a one-to-one function, and I'll ask you to think about that before I show you why. And the reason is, if I take the derivative, g prime of x, its domain is all possible values of x, and if I take its derivative, that's 2 minus sine of x, and that function is always positive. The reason for that is because sine of x is always between -1 and 1, so 2 minus sine of x is always greater than 0. I'm looking for g inverse of 1, and so I know that g inverse of 1 equals x is the same as saying, I'm using the if and only if symbol, is the same as saying that 1 is equal to cosine of x plus 2x, or g of x equals 1. Now I just need to solve for x in the equation 1 equals cosine of x plus 2x. There's no easy way to solve this equation, so in this case we're going to guess, because it's easy enough to see what that unique x which solves the equation should be. So remember, cosine of 0 is 1, so cosine of 0 plus 2 times 0 is 1, and therefore x equals 0 must be that unique value of x which solves this equation. So therefore, g inverse of 1 equals 0, and in this case, we actually had to use guesswork to solve the equation g of x equals 1. Note that the domain of f inverse is the range of f and vice versa. Let's look at the function g of x equals the square root of 4x plus 4. Remember, we've already established that this is a one-to-one function, so it should have an inverse. And its domain is going to be all of x, so that 4x plus 4 is greater than or equal to 0. And so it's going to be all x, so that x is bigger than or equal to minus 1. And the range is going to be the same as the range of the square root function, which is all y values where y is bigger than or equal to 0. Does g inverse exist? Well, yes, because we've already established that this is a one-to-one function, and every one-to-one function has an inverse. What's the domain and range of g inverse? Well, the domain of g inverse is the range of g, so that's going to be the set of all x, so that x is greater than or equal to 0. And the range of g inverse is the domain of g, so that's going to be all x, so that x is greater than or equal to negative 1. How could I find g inverse of 4? Well, I can use the method I've just described. G inverse of 4 equals x is the same as saying that g of x equals 4. So I need to solve for x in the equation the square root of 4x plus 4 equals 4. I square both sides, I get 4x plus 4 equals 16. Gives me 4x equals 12 and x equals 3. So g inverse of 4 equals 3, and if you check, g of 3 should be equal to 4.